today we're looking at ScatterPlots once more. Your standard is to construct, interpret ScatterPlots from bivariate measurement data to investigate patterns of associations between two quantities. Describe patterns such as clustering, linear association, and nonlinear association. The objective today is I can construct a scatterplot and describe patterns. Your sub-objective is to understand positive, negative, and no association, identify linear and nonlinear associations, understand strong and weak clustering, know how to plot points on a graph using a table. Okay, we are going to construct a scatter plot, and what I want you to do is I want you to look at how I have my X and my Y labeled. This is my X and this is my Y. I want you to notice that I have it labeled distance from goal, and my Y is labeled baskets made. I have my data points, my graph labeled, so I have 4, 8, 12, 16, 20, 24, 26, 2, 4, 6, 8, 10, 12, 14. I want you to pause the video and I want you to label your graph on your paper to look just like mine, and then we'll continue on. Okay, so what I want you to notice is I've taken a picture of my paper that's already filled in just because it's very difficult for me on the iPad to label everything neatly so that you can see it. So I'm just going to go ahead and go over what I've done here. It says that Jared's basketball team stood at a various distance from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal and the number of baskets made is shown in the table. So we have our table below, and we have basketball players' names here, and we have the distance they stood from the basket here and the number of baskets they made. So obviously my independent variable is going to be the distance from the goal they stood. So I'm going to label that as X, and the baskets made is my dependent variable, and that's going to be Y. So I'm going to go ahead and I'm just going to put red points over where I have plotted my points to begin with. So I started out with Jared, and he was 14 feet from the goal, and he made 4 baskets. So I went over here between the 12 and the 16, and I put a point there at 12 and 4. Then I'm looking at Tyrell, who was 25 feet from the goal, and he made 6 baskets. So he is about right here. So now we're looking at Anthony, and he was 27 feet from the goal, and he scored 7 baskets, and I think I put his here on the very end right there. Mark is 15 feet from the goal, so he's in between this 14 and 16, and he scored 11 baskets, which would be about right here. And then we have CJ, he was 26 feet from the goal and scored 6 baskets, which would be there. Kevin was 16 feet from the goal and scored 13 baskets, so he is right here. Wade was 15 feet from the goal and scored 12 baskets, so he's here. Kyle was 26 feet from the goal, and he scored 14 baskets, so he is technically up here. And looks like Tim is 28 feet from the goal and 5 baskets, which he didn't even make. He's not even on the graph. So you see how I have this labeled. So I answered the question here, and it says, what type of association do you see in the scatter plot? List any other observations in the space below. Well, what I see is a negative association, and the reason why I see a negative association is because as the distance from the goal got further away, so it increased, the number of baskets decreased. So my points moved in opposite directions, and as my X increased, my Y decreased. So therefore it has a negative association, and the points seem to have a gap between them. There is also one point that doesn't fit the pattern, which would be right here. and he would actually be called an outlier. So this is how you construct a scatter plot, and then describing whether it is positive or negative association. So now we're going to look at number 2 based off of your graph that you constructed. And it says, use the scatter plot to label each statement as true or false. So we're looking at the scatter plot from the previous screen, which is on your paper. So A, it says, as the distance from the goal increases, the number of baskets made decreased. Well, that is a true statement, because as you can see on your graph, the further from the goal the kids were, the boys were, the number of baskets got smaller and smaller, so it decreased. B, as the distance from the goal decreases, the number of baskets made increases. And that is also a true statement, because as you can see, that the closer they were to the basket, the number of baskets that were made. And as the distance from the goal decreases, the number of baskets made decreases, and that's false. Because you can, as you can see, the further away, the less baskets that were scored. So the number of baskets decreased as well. So let's look at outliers and clustering. A point that does not fit the overall pattern, and that's what we had seen in this previous point. We had one that didn't fit the pattern, or a trend of scatter plot is known as an outlier. And that's what we had seen in the previous scatter plot that you looked at. So who was the outlier in the scatter plot above? Well, it was Jared. You can see that. He was at 15 feet, or it looks like 14 feet, and scored 4 baskets, and he was the first one. So Jared, and the reason was the number of baskets was lower than the rest. Of his teammates, and who stood similar distances from the goals. As you could see, looks like there were 4 other players that stood similar distances and scored a lot more baskets than he did. So Jared would be your outlier. Another thing is clustering. Clustering occurs in a scatter plot when there are distinct or separate groups of points. So why do you think clustering occurred in the scatter plot above? Well, it seems that a group of players stood closer to the goal, and a group of players stood further away from the goal. So as you could see, you had a group of players who were closer to, who stood further away from the goal. They scored less baskets, and there was a group of students who stood closer to the goal and scored more baskets. So you could say what you would want to write down is group stood close to the goal, and a group stood further from the goal. Okay. Okay, so let's look on the next page. It says the population of 10 cities and the number of elementary schools it has is shown in the table. Make a scatter plot of the data. Okay, so what we're going to do is we notice that population is already labeled, and that's going to be your X. And the number of elementary schools is labeled, and that's going to be your Y. So I'm just going to put an X here, a Y here. Also, I'm going to put an X here and a Y here just so I don't get anything mixed up. So I'm going to start out with this first school right here. Lawton, it has a population of 76,000. So what I need to do is, I notice that there is this in between line right here is another 10,000. Okay, so it goes up by 10,000s. So I'm just going to have to really estimate where 76,000 is. It's going to be in between here and here. So it's probably going to be it's going to be right just a little bit over from the center a little bit. So we have 76,000 people and we have 19 elementary schools. So I'm going to go up the center and I'm going to label it right in between 18 and 20, which will be right here. Okay, so then we have Moore, which has a population of 60,000. And it's going to be right in between here, between 50 and 70. And they have 17 elementary schools. So it's going to be just right below the 18 and 16 in between. We have Lufkin, which has 35,000, which is going to be right in the center, and they have 10 elementary schools. We have Cheyenne, who has 73,000 people, and they have 22 elementary schools. So it's just going to be right off the line, about right there. Danville is 51,000 and 13 elementary schools. So it's just going to be, it's going to be really right on the line itself as well. And it's going to be in between 12 and 14. I'm here at Madron, which is 78,000. And they've got 26 elementary schools. So it'll be close to the 80,000 mark. And we have 26 schools. So we're going to be right there. Weatherford has 25,000 and 12 schools. So we're going to be in between the 20 and the 30. And they have 12 schools, which is going to put them about right here. I have Prosper, who has 13,000. Which is right past the 10,000 with 7 schools. And we have Glen Falls with 20,000 people and 20 schools. And we have Dalton, who has 85,000 people with 21 schools. So there you go. Okay, so this is our scatter plot. So make sure that you have paused the video long enough to go ahead and finish filling out the scatter plot if you didn't fill it out with me. Okay, so now we're going to just answer some questions. We're going to answer 4, 5, and 6. And you need to look at the scatter plot as I describe why I'm answering these questions the way that I am. So the first one is, describe any association between the variable and what conclusions can we make? Well, when I look at this, I want you to notice that as your x is increasing, so is your y. So they're increasing together. So therefore, we have a positive association. And as the population increases, the number of elementary schools increase. And this is the reason why we have a positive association. So as the population increases, the number of elementary schools increase. Okay, so question 5. Are there any outliers in the data? Well, yes, there is an outlier in the data, and it looks like it is Glen Falls. So our answer is yes. And it is Glen Falls. So look at your data and notice that it is Glen Falls because they had 20,000, population of 20,000, and they had 20 elementary schools. So they have much higher pattern, much higher number of elementary schools versus their population. So so that data point would be 20, which is your x, and 20,000, which was your y. So this is higher than the pattern of data. And number 6, is there any clustering in the data? No, there is no clustering. Everything looks to be equally spread out, so there's no clustering in the data. So I'm going to write there are no distinct groups of data. Okay, so now let's look at the next table in ScatterPlot. On Tuesday after school, Charlie asked 9 different students how much money they had in their lunch account, as well as how many homework assignments they had that evening. Use the data he collected to make the ScatterPlot. Okay, so we know that the amount of money in the lunch account is X, and the amount of homework assignments is Y. So I'm going to label this X and this Y. So I'm going to go ahead and plot my points. So the first one is $8.24 in the account and 0 homework assignments. So I'm going to put it right about here. And the next one we have is $29.05 in the account and 2 homework assignments. Then we have $4.75 in the account and 1 homework assignment. Then we have $20.01 in the account and 0 homework assignments. We have $1.80 in the account and 3 homework assignments. We have $11.92 in the account and 4 homework assignments. And we have $0 in the account and 1 homework assignment. We have $17.50 in the account and 2 homework assignments. And then we have $26.11 and 3 homework assignments. Okay, so looking at the scatter plot, let's answer A, B, and C. So A says describe the association between the variables. What can you conclude? So the association is none. There is no association here. The amount of money in the student's account has no effect on the number of homework assignments. So my conclusion is the amount of money in a lunch account has no effect on the number of homework assignments. And I'm just abbreviating homework and assignments. B, are there any outliers in the data? Well, there's no association, so there's no outliers in the data. So no outliers. And C, is there any clustering in the data? No, there's no clustering in the data, so we're going to say no. And the reason why is the scatter plot does not show an overall pattern. So the reason why is there is no overall pattern. Okay,